Assalamualaikum warahmatullahi wabarakatuh. Today, I will present to you about our project regression model for flood forecasting case study rainfall in Malaysia. So our dataset is about the rainfall in Malaysia only from 2000 to 2010. Our group has four people, and we have me as a leader. My name is Muhammad Farid bin Muhammad Yusof. My metric number is S2280080. And my friend will continue the video. He will start with introduction and background.
I will continue. My name is Muhammad Shafiq Ikwan bin Muhammad Basri. My metric number is S2280026. Uh, Now I want to tell you about background our projects. As we know, Malaysia monsoon season bring heavy rainfall and frequent floodings, disrupting architecture and damaging infrastructure. This lead to cross loss, transportation delay, and economic challenge, especially on the East Coast. Next is about linear regression. Linear regression is a simple statistical method for modeling relationship between variable. Uh, it's called linear regression. It is widely used for forecasting and analyzing to its explanations, allowing easy understand of how change in one variable affect another. Okay, next the objective. First, to develop machine learning model utilizing linear regression to analyze, then predict rainfall pattern and assess flood risk in Malaysia. Second is to focus on flood prediction, the amount of annual rainfall based on monthly and years rain data. And the last is to utilize Malaysia rainfall data sets with annual rainfall as the target variable to ensure rainfall monthly specific that can lead the flood risk assessment.
Okay, Assalamualaikum. My name is Muhammad Arif Zakwan bin Muhammad Zaid. My kinetic name is S22B0022. My part is methodology. We have five methodology. Before we go to pre-processing, we need to have a dataset. We use dataset from National Center for Environment Information. In dataset, we have state, district, year, month, annual rainfall, and flow. For second step is pre-processing. Pre-processing is step for preparing raw data for analysis or modeling. In pre-processing, have a handle missing value, which is detect missing data in two category, which is numerical and categorical data. Pre-processing also have normalized data. Third is we need to identify variable. For my dataset is predict monthly rainfall, which is January into December. Target is annual rainfall. After we identify the variable, we need to perform evaluation like MAE, mean absolute error, MSE, mean square error, and R square. The final method we use is ADA, exploratory data analysis. It's not about data set before into solving problem. Is process of exploring and summarize data. Also, ADA have visualized pattern using scatter plot and heat map. In my dataset have descriptive statistic. January mean rainfall is 193.99 millimeter. Annual mean rainfall 2498.53 millimeter. For correlation, in March January, which is 0.73, February 0.68, and March 0.757. And last is outlier. In March January have 37 and annual have 24.
Okay, my name is Petan Ramadan Prasetyo. My card number is S22A0093. So I will explain about result. For the result, we have four results. For the first, we have MSE, mean square error. Mean square error, we have a very low value of 0.0010123. For the second one, we have MEAE, or mean absolute error. For the mean absolute error, the small error of 0.0007 confirms the high precision of the model's predictions. For the third one is MIPE, mean absolute percentage error. For this, we have a 0.00% mapping. Highlight the model's predictions are almost identical to the actual values. For the last part is R2 square. For R2 square, we have a near perfect score of 0.9999, suggests the model explains nearly all the variance in the target variables. For the next page, I will explain about visualization. For visualization, we have four graphs. For the first graph, we have correlation matrix heat map. For correlation matrix heat map, we know that January, February, and March as connection with annual rainfall as a dependent. So for our group, take January, February, March as a sample correlation analysis. For the next graph is comparison year and annual rainfall. We know from this graph the highest rainfall is 2008 and the lowest is 2000. The next graph is linear regression compare actual versus predicted annual rainfall. From this graph, we know that uh, the line of linear regression is perfect with the plot. So for the next graph, we have data plot comparison actual versus predicted values. For this graph, we know the accuracy data plot from 0 to n is perfect or accuracy is 100 with the target variable. So is it approved with linear regression?
I will talk about our discussion. For this project, we will discuss about how linear regression model works as a best tool. So, for analysis, the analysis result that January, February, and March rainfall occurring has a strong influence on the probability of the flood that happened. The distribution plot analysis is a non-linear alignment between the actual values and the predicted values. From the result, we can see that we get the accuracy with 100% percentage. This means that we predicted that the predicted value will be same like the actual value. Next, we can discuss about the model accuracy. The model accuracy remained high despite significant fluctuation in 2008. In 2008, we have a highest rainfall occurred. This indicates that the reliability of linear regression for the forecasting function throughout the long period. While we using the dataset in 2000 until 2010, 2008 has the highest rainfall, right? So this means that 2008 can have much possibility to have a flood. With the predicted, result, we can predict that flood will be happen in 2008 more than other months. So next is the conclusion.
Okay, for lastly, for conclusion, I want to make a summary. Linear regression accurately predict rainfall and floods, and high performance with low error and near perfect R square. Next, the impact that we get is early rainfall data is vital for disaster planning. With yearly rainfall, data, we can get much benefits such as preparation for flood. For future research, the picture can add variable like temperature to get a better prediction and extend analysis to longer periods. So with our perfect accuracy, this show that linear regression model can be best told to predict rainfall and flood in Malaysia. That's all. Thank you.